Hello class, welcome to lesson 29. This is on systems of nonlinear equations. Okay, so we're going to take a lot of these ideas that we've been messing with when it comes to systems of equations and stuff like that, and now we're going to apply it to nonlinear systems. Well, the thing is, nonlinear systems are solved in much the same way as the linear systems. Okay, so let me just start with an example. Okay, say we have an equation like this: x squared plus y squared is equal to 80, and x minus y is equal to, actually, it's supposed to be a 4. Okay, so as you see, it's a system of equations, but now we have like quadratics here. We have x squareds, we have y squareds. But the goal is still to solve both of these simultaneously. All right, so the goal is to solve both simultaneously. Okay. We'll talk about, once we solve this one, what it is we're doing, say, graphically. But a lot of the techniques are the same. Okay, the techniques are basically the same, are essentially the same. Okay. We have our two methods. We have substitution method. We also have the addition method. So the substitution method, okay, works in the same way. You try and solve one of the equations for a variable, and then plug in what you have into the other one. So we're going to solve for one variable, say x or y, and plug that expression into the other equation. Okay, so it's very much the same, except we have like x squareds and x cubes and y squareds and xy's and other things that are nonlinear. Okay, so but we will still kind of approach it in the same way. It just complicates things. It means we'll have maybe more than one solution. So let's rewrite this equation and get started with it. Okay, and you'll see that it has a lot of the same sort of behavior. Okay. Okay, so here's our problem again. It's x squared plus y squared is equal to 80, and we have x minus y is equal to 4. Okay, so again, like I've done in the previous lessons, I'm going to call, say, the top equation equation 1, and the bottom equation equation 2. And for my substitution method, I'm going to start by solving equation 2 for x. And I'm picking that because actually that will be the easiest thing to solve for, I think, because to solve equation 2 for x, all I have to do is move that y over and we're done. We don't have to then divide, or I definitely don't want to start with these because I have square roots and other stuff. I always jump to which equation looks the simplest. Sometimes there isn't one. But in general, if there's one that looks the simplest and the simplest way to do it, that's what I'm going to do. So when we do that, say I move that y over, I'll get that x is equal to y plus 4 when we move that to the other side. Okay, so now we have that x is equal to y plus 4. I'm going to put a box around that because we're going to use that in a little bit. And now I'm going to take this expression and plug it in to the other equation. So we're going to take this and plug it into the other equation. In this case, that will be equation 1. Okay, so note I have that x is equal to y plus 4, so I plug that into here. So equation 1, so it's x squared. So it's going to be this entire thing, y plus 4, all squared when we bring it down. Okay, so that's what we're going to get here. Okay, so I have y plus 4 all squared plus y squared is equal to 80. Okay, and now I have an equation in just y. Okay, so it's a little different though, because now it's not just a linear equation in y, now it's going to be a quadratic equation in y, but we'll solve this like we've solved previous problems before, right? I'm going to expand this out, and since it's a quadratic, I'm going to move everything over and have 0 on the other side in case we can factor it, all right? But we're going to expand this out, so remember, careful when you do this. This will be y squared, okay, plus 8y plus 16. I know it's really easy to forget that, but if you need to write out your y plus 4 times y plus 4 and, you know, FOIL that out, however you need to do it, make sure you do it. Then we'll have plus y squared is equal to 80. Okay, so all I did was FOIL that out. That's a common mistake I even see in my calculus students making. So now I'm going to combine my like terms and move the 80 over. So I have 2y squared plus 8y plus 16, and it's going to be minus 80. So we get negative 64. Excuse me. So now we could go through our usual solving of quadratic stuff here. But what I'm going to do, since I see everything's even, I'm just going to divide everything by 2. Simplify it all a little bit. Okay, and the 0 too. So I'll get y squared plus 4y minus 32 is equal to 0. Okay, and I believe this factors. We want factors of negative 32 that sum up to equal 4. And let's say 8 and negative 4. Yeah, 8 times 4, or negative 4 would be negative 32. 8 minus 4 would be 4. So this factors into 8, or y plus 8 times y minus 4. You can always use quadratic formula or however you want to actually solve this. And so we get that y is equal to 4 and negative 8. Okay, so we have 2 y's. Now, when we go back, we need to, when we go to find our final thing here, okay, we need to plug our y's back into this to get our x. So x is equal to y plus 4. So when y is equal to 4, and I should really be careful with my y's and 4's so they're not, I'm just now realizing that they kind of look the same. When y is equal to 4, x is 4 plus 4, which is 8. So we need to be really careful about this. So we have the point 8, 4. Okay, we need to make sure that they join together correctly. Okay, when I have that y is equal to negative 8, x will be negative 8 plus 4, which is negative 4. So we now have the point negative 4, negative 8. Okay, so our solution set is these 2 points. Okay, so the solution set is the point 84 and the point -4, -8. Okay. And there we go. So, like I said, it follows the same process. It follows the same overall steps. There's just a little more to it, and we can have more than one solution now. So it's actually worthwhile to talk about the solution set, because it actually can be a set now. Okay, so let's talk about graphically what's going on here. Okay. Okay, so let's talk a little bit about what's going on when we solve these systems of equations. Like we talked about it before, when linear systems of equations, it was two lines. And they're either going to intersect at a point, or, you know, if the lines are parallel, they would never cross. Or they might be the same line and they cross everywhere. But this, if you remember back to when we talked about it, this x squared plus y squared equals 80, this is a circle, and it's centered at the origin, 0, 0. Okay? And its radius is the square root of 80. And so the square root of 80, we can take that out. That's 16 times 5. So the square root of 16 is 4. So this is 4 root 5. You know, it's not necessary to know that this is a circle. That just gives an idea of, you know, what about what radius it has. And then this is the line. Okay, we can solve this for y. We solved it for x before because that was easier, but if we want the line, we want it as y equals mx plus b. So we'll do negative y is equal to negative x plus 4. And then dividing everything by -1, I'll get that y is equal to x minus 4. Okay, so it's a line. Its slope is 1. Its y-intercept is 4, or -4. Okay, so what is happening here, okay, is we have a circle of radius 4 root 5 centered at the origin, and then we have this line here. If you can see that, you can see half of it. Okay, so here's my circle. Now this is not drawn perfectly or to scale or any of that, but here's our circle. X squared plus y squared is equal to 80. Here's our line, y equals x minus 4. And we see that these two intersect, okay, at 2 points. And the points we found were -4, -8. So this would be -4, -8. Okay, and this one was 8, 4. Okay. Now, again, I did not draw it great into scale and all that sort of stuff, but you can almost see, if you drew this on a grid and made it perfect, you would almost see how it lined up. Okay, but this is basically what we're doing. We are finding where these linear or nonlinear or whatever it is we're talking about, we're finding when those graphs intersect. What are the points where they overlap one another? Okay. All right, let's look at another example. Okay, let's say we have the system xy equals 24 and 2x minus y is equal to -2. Okay, so I'm going to use a substitution method, but look at the, hopefully you can start to see how complicated this can get, all the different directions, because yeah, we had x squared and y squared before, but now instead of x squared, y squared, I have x times y. Okay, so what we're going to do is, again, we're going to solve one of our equations for one of our variables, okay, then plug it into the other one. So I'm going to solve equation 2 again, but this time I'll solve it for y. So let's solve equation 2 for y. So once again, just like the other ones, it's not always going to be equation 2. This one just happened to be easier. I don't want to mess with this one, okay? This one, all I need to do is move the 2x over. Right? When you do that, you get negative 2x minus 2. And then I could just, if everything's negative, I could divide everything by negative 1 and make it all positive as y equals 2x plus 2. Okay. Right, then I can take this and plug it into equation 1. Okay. So if y is equal to 2x plus 2, I'll plug that into y in this first equation. So we'll plug this into equation 1. Alright. So equation 1 becomes, so 1 is x times y. So it'll be x times this 2x plus 2. Right there, is equal to 24. Okay? And now we have an equation, just an x. We're going to solve it. All right, solve for x, and then plug those x's back in. So it's like a, you know, a chain of solving, essentially. Again, this isn't new. This is just like, you know, systems of equations that we've seen before, except now when I say distribute this x, I'll get 2x squared plus 2x is equal to 24. And that part's different. Okay. Now I have a quadratic. So this is a quadratic in x. Okay, so a little more involved in solving, but not that bad. That's one of the earlier solving techniques we looked at, were the quadratics. Once again, before I get started, I'm going to just divide everything by 2, because everything's even. Right, so that will simplify things a little bit for me. So I have x squared plus x is equal to 12. All right, I'll move the 12 over. Always do that unless you have 0 over here. But always make sure you do that with quadratics. So now we want factors of negative 12 that will sum up to be 1. 4 and negative 3 is what I'm thinking. Because 4 times negative 3 is negative 12. 4 minus 3 is 1. So we get x plus 4 times x minus 3. So x is negative 4 and positive 3. Alright. Now, when I've done, I know it's really, really common to think you're done when you find x, but remember we're finding both x and y simultaneously. So we need to plug this back into our y. So when x is negative 4, so remember our y is 2x plus 2. So let me write that again. Y is equal to 2x plus 2. When x is equal to negative 4, y is equal to 2 times negative 4 plus 2. Okay, so we have negative 8 plus 2 will be negative 6. So that gives us the point negative 4, negative 6. And then when x is equal to 3, okay, we get y is equal to 2 times 3 plus 2. Alright, so now we'll have 6 plus 2, which will be 8, which gives us the point, we can fit it in here, 3, 8. Okay, so the solution set is negative 4, negative 6, comma, 3, 8. And there you go. That's that. If you want to check your work, okay, you plug each one of these in to see if it satisfies both simultaneously. Okay, so what that means is if I were to plug both a negative 4 and negative 6 in, so negative 4 times negative 6, if I multiply those two together, I get 24. So that satisfies the top one, number 1. But in 2, it will be 2 times negative 4 minus a negative 6. Okay, so that will be negative 8 plus 6. It comes out to be negative 2, and there we go. That satisfies 2. So it has to satisfy both simultaneously at the same time. That's what we're trying to find. Okay, we can find plenty of things that will make this work just for the top one. Right? We can find tons of x, y's that will make x times y equal 24 on the top. For example, 2 times 12, so let x be 2 and y be 12, but that's not going to solve the bottom one. So we're looking at 4 values that will solve both the equation 1 and equation 2 at the same time. And this is also going to be points where, say, both of these curves intersect each other. Alright, so this one's a little tricky. Well, it just kind of mixes the two things that we just saw together. So, as I mentioned, there's a lot of possibilities here. There's a lot of stuff going on. So I'm not going to be able to show you every single possible thing you could ever run across. But hopefully, with seeing enough examples, you'll get an idea of how to tackle these. So once again, we're going to solve for one of the variables and try and plug it into the other equation. So this one, we don't have a linear piece. I have my xy equals 3, and then I have this circle here. So neither one of these are linear. That's usually what we leaned on before for our easier solving things, since linears are, you know, pretty nice, respectively. So what we're going to do is we're actually going to solve equation 1. And it doesn't matter which one you solve it for. I'll just solve it for y. Either one will be just as easy. Okay, it's not going to matter that much. And how we do it, this is a little different. Let's do it over here. xy equals 3. If I want to solve for y, okay, and I want to get y all by itself on this side, I'm just going to divide both sides by x. Now, we have to be very careful when we do this. X, when we do this, is not allowed to be 0. Why? Well, because we'd be divided by 0. Right? We're not allowed to do that. But we're intersecting. First of all, there are a couple reasons why x can't be 0. If x were 0, we'd get 0 equals 3. So that's not going to happen. Also, this equation here is a circle, and it will never touch the origin. It's centered around the origin. So we don't have to worry about this, but in general, whenever you divide by x or y, you want to make sure that it's not equal to 0. Whatever you're dividing by isn't equal to 0. You can have a lot of problems there. Okay. Now, I'm going to take this and plug into equation 2. Okay, so here we're going to plug this in to our y squared. Now, you'll notice I'm always avoiding, it's not just for the simplicity's sake, I'm always avoiding these squares when I can, because solving for those is going to involve some really kind of unfun stuff. So if we can avoid it, it's my advice. All right. So that means 2 becomes, the x squared doesn't change, but y squared. I'm going to take my y, which is 3 over x. square all of that. Say that that's equal to 10. Okay, so we're going to simplify this. 3 over x all squared, that's going to be 9 over x squared, right? Because you can square the top and the bottom, and that's equal to 10. Okay. Now what we're going to do is we have this fraction that we don't really like, and remember, when we have fractions, we can always multiply by the denominator, that, you know, or something that will get rid of the denominator. In this case, we only have the one denominator, so we'll multiply by x squared. Maybe I should use the dot here, so we'll dot by x squared. So what ends up happening is you get x squared times x squared plus x squared times 9 over x squared is equal to 10 times x squared. So that your x squareds here cancel. And so what you have is now x to the 4th plus 9 is equal to 10x squared. Okay. Alright, so now we have an equation just in x, and it's a degree 4. But it's degree 4, but almost quadratic. So this is degree 4 in x, almost quadratic. What do I mean by that? Well, when I move that 10x squared over, I get x to the 4th minus 10x squared plus 9. I think I said 10x here. But so I get x to the 4th minus 10x squared plus 9. So if you remember back to our, gosh, some of the early lessons, this one's really kind of mapping back. If you remember this, this is, I have x squared here and I have it doubled here, x to the 4th. So if you let u be x squared, right, that tells me that u squared is x to the 4th. So you remember, hopefully, that when you have almost quadratics, quadratic patterns. So this is actually u squared minus 10u plus 9 equals 0. Right? And that we can actually factor. Right? Factors of 9 that sum up to be negative 10 would be negative 9 and negative 1. Right? Because negative 9 times negative 1 would be positive 9, while negative 9 minus 1 would be negative 10. So we get u minus 9 times u minus 1 equals 0. So u, put it here, u is 9, or u is 1. Okay? Well, we weren't solving for u. We were solving for x, and u is equal to x squared. So we just put those things back in. We get x squared is equal to 9, and x squared is equal to 1. And this seems kind of involved. We're actually utilizing a lot of tricks that we've learned in this class so far. And so, if you haven't kept up with them, well, this is really going to stretch you a bit. If you have, then what you're seeing is all of these things you've been learning coming together all in one thing here. So anyway, when you have x squared is equal to some number, that means x is equal to plus or minus the square root of that number. So x is either plus or minus 3, or it's plus or minus 1. Okay? So we have 4 possibilities for x. I'm going to list them all out. It's going to be my positives, 1, 3, and then my negatives, negative 1, negative 3. Okay? I'm listing them all out because I need to plug those into my y formula. And I need to be really careful about it because we have to make points out of this. Okay, so I'll do that over here. Y, if if you remember, if we go all the way back up here, y was 3 over x. So I'm going to use that. Okay, and I'm going to set up a table. Okay, since I have 4 values here, I'll set up a table, and so I have 1, 3, negative 1, negative 3, and this is just to make sure I keep everything aligned and mapping to the right thing. So when x is equal to 1, 3 over x will be 3 over 1. So that's just 3. So I get the point 1, 3. Okay. When x is equal to 3, y is 3 over 3, so I get 1. So I get the point 3, 1. Okay. When x is equal to negative 1, y is equal to 3 over negative 1, so that's negative 3. So I get the point negative 1, negative 3. And when x is equal to negative 3, y is 3 over negative 3, so we get negative 1. So we get the point negative 3, negative 1. Okay, so here is my entire solution set. 1, 3, 3, 1, negative 1, 3. Zoom in a bit so it's easier to see these. Negative 1, negative 3, and negative 3, negative 1. Okay. So there are a lot of places where these intersect, right? But here's what's happening. Let me show you a little bit what's going on with these two functions. Okay, as we've discussed, this x squared plus y squared equals 10. This is a circle. It's centered at the origin. Its radius is square root of 10. So it looks like this. Here's my square root of 10. Okay, xy equals 3. Well, that if I move that x over, this y equals 3 over x. Y equals 3 over x makes functions that look like this. Okay, so it does cross the circle depending on how large the circle is, right? And it should be balanced. I'm not graphing this well, but it does cross the circle 4 times. And notice our options for our solution set were 2 positives and 2 completely negatives, not any intertwined, not anything where, say, I had negative x's and positive y's, or positive x's and negative y's. It was in quadrant, clear from the points, quadrant 1 and quadrant 3. Okay, let's look at this next example. I don't know if I drew that very well. It's x squared plus y squared is equal to 25, and y squared minus 4x is equal to 25 as well. Alright, so we have our equation 1, we have our equation 2. Neither one of them is neither one of them is a linear, nice sort of equation. So what I want to show with this one, there are a couple ways we can go about it, actually. And I want to just show how many sort of different methods there are out there that can say vie for your attention. One we haven't looked at is we can still use the addition method. And I'm certain a lot of you out there don't really like the addition method, but it can be really efficient when used correctly. For example, what I see is I have a y squared and a y squared. So if I negate one of these equations and then I add, the y squared should cancel. So if we negate equation 2, okay, and I just picked equation 2 mainly, well, because it would make the 4x positive, but you know, it would work with 1 as well. But if we negate 2 and the y squareds will cancel. Okay, so let's do it. Negative 2, so if I negate 2, right, you'll get negative y squared plus 4x is equal to minus 25. Okay, then I'm just going to add 1 directly to that. I have an extra equal sign there. 1 is just x squared, and I'll actually flip this so that everything kind of matches. So I have a y squared plus an x squared. You don't have to do this, but you know, if you want to actually see things cancel. So when we add these together, the y squareds cancel, and then here, these aren't like terms. Okay, so that's the thing to keep in mind here. It's 4x plus x squared. That's just going to stay x squared plus 4x. There's not really anything we can do about that, but also the 25's cancel, and we get 0. Okay? So, after that, we now have an equation just in terms of x. Alright, so this is just an x equation. And so we'll solve it. And this one, much nicer to solve than some of the other ones we've seen so far. I can just factor out this x. Get x times x plus 4 is equal to 0. So x is equal to 0, or x is equal to negative 4. Okay? Alright, now, I guess the question then is, well, what do we plug this into? Because using the addition method, we never solved anything specifically for y. So here's what we'll do. If I plug in 0, okay, so let's plug in 0 into both of our equations. So over here, let's plug in x equals 0. Okay. When we do that, in equation 1, the x squared goes away. So equation 1 becomes y squared is equal to 25. Okay, and then equation 2 also gives me, well, the minus 4x goes away, and we get y squared is equal to 25. Oh, I guess y squared must be equal to 25. So, what that means is that y is equal to plus or minus 5. Remember, it's always plus or minus the square root. If you are doing this on MyLabs Plus and you're putting in some answers and you're missing some, it's telling you some things are wrong and you're seeing some minuses, that's probably what's happening. Okay? Now, these are both for x equals 0. Okay? So we get both of these for x equals 0. So we get 2 points out of this. We get 0, 5 and 0, negative 5. Okay? So that's, be careful about that too. We plugged in x equals 0 and we got 2 y's out of that. Okay? Now I'm going to plug in my negative 4. So when we plug in the negative 4, this so you can see it. When I plug in negative 4 into equation 1, we get negative 4 squared plus y squared is equal to 25. So we get 16 plus y squared is equal to 25. When we plug in it into equation 2, well, equation 2 is y squared minus 4 times x. Well, x is negative 4 equals 25. And look at what happens now. We get y squared plus 16 is equal to 25. So in both cases, it really doesn't matter which one you plug it into. You just need to make sure you do both at negative 4 and 0, but you'll get the same thing out, right? You'll get 16 plus y squared is equal to 25. Alright, so 25 minus 16, that gives us y squared is equal to 9. So y is equal to plus or minus 3. Okay. And once again, x equals negative 4 gives us both of these. Okay. So we get both points, and from this one, x is negative 4, and we get positive 3. When x is negative 4, we also get negative 3. So we have a whole solution set here. 0, 5, 0, negative 5, negative 4, 3, negative 4, negative 3. Okay? Every possibility. All right, and again, what's happening here? We have a circle of radius 5. That's one of the things we started with, and this is actually this is a parabola. And if you think about a parabola and a circle, it's possible that a parabola can cross at 4 places, and specifically they'd be balanced across the y and the x in certain ways, which is basically what we see from our solution set here. Okay, but addition method is not the only way to solve this equation. In fact, some of you might have looked at this and thought, well, hang on, 25, if x squared plus y squared is equal to 25, but 25 is also equal to y squared minus 4x, can't I just say that these things are equal? Right? And like remove that 25 if both of them are equal to 25. Doesn't that mean that just x squared plus y squared is equal to y squared minus 4x? Well, let's see what happens if we do that. If we subtract y squared on both sides, we see that they cancel, and if I add 4x to both sides, we get this equation here, x squared plus 4x equals 0. Well, what do you know? That's exactly what we got over here using the addition method. Right? This same exact equation. Okay, and some of you may have even thought, well, hang on, maybe I can use substitution in a different way. If y squared minus 4x is equal to 25, then that means y squared is 20, well, if I move the 4x over, I get 4x plus 25, that's equal to y squared. And instead of solving for y directly, you may have looked at that and thought, well, I'll solve for y squared because that's what I have here. If y squared is 4x plus 25, and I have a y squared in equation 1, what happens if I just plug that in directly? Well, if you do, let's do that over here. You'd get x squared plus 4x plus 25 is equal to 25. You subtract 25 on both sides, they cancel, and you get down to x squared plus 4x is equal to 0. And, well, check that out. That's, again, the same thing we had before. Okay? So there are many different ways to approach these, and you should, any way you go, end up with the same stuff. There might just be some paths that are easier or nicer than, you know, maybe the one you might originally think, but still, as long as you're careful and you do everything correctly, it shouldn't really matter the path that you take. Okay, let's check out this example. So we have x squared plus y plus 6 all squared is equal to 25. And then our second equation is x squared plus 5y is equal to negative 5. Alright, so a couple things here. This is still a circle up here. It's got radius 5. It's just not centered at 0, 0 anymore. It's now centered at 0, -6. Okay, so there are a couple of options here as far as how we can solve this. Okay? I'll start with a substitution, because the first thing I see, okay, and this isn't a full substitution. I like to think of this as a half substitution, or a partial substitution. Okay, it's because we're not going to solve, and it's kind of like what we saw in the previous one. I'm going to solve equation 2, because that's a simpler one, because, you know, we got all this junk going on. I'm going to solve equation 2, but I'm not going to solve it for x. I'm going to solve it for x squared. So we're going to solve 2 for x squared. Okay, so, and that really all we have to do is move that 5y over. So when we do that, I get that x squared is equal to -5y minus 5. Okay, then we plug into 1. And I get questions sometimes if, as you know, a student, you have to write all this stuff out when you solve the problems. And I always do it just so I keep track of what I'm trying to do. You know, whenever I go back to look at what I've done, if all I see is a little bit of work and maybe they're the right answer, I might not know exactly how I did that. So anyway, when I plug this into 1, so now I'm going to replace this whole x squared by -5y minus 5. So I don't have to solve for x and then square it, because I would get, say, plus or minus the square root of all this stuff, and then I would square it here. It's actually a bit redundant to do all those steps. So 1 just becomes this -5y minus 5, then plus y plus 6 all squared equals 25. Now we have an equation just in terms of y. It's a messy equation, but still, this is just in y, so we can solve for y like normal. And I say like normal as if any of this is normal, but you know, like we have before, I guess is what I really mean to say. Okay, so to do that, we're going to FOIL this out. So remember, that's y plus 6 times y plus 6, so be sure you FOIL it all out like before. But this will stay the same. I'll have -5y minus 5. This will become y squared plus, you have a y times 6, so a 6y plus a 6y, so plus 12y, plus 6 times 6, which is 36, is equal to 25. Alright. Now, what we're going to do is I'm going to collect everything over here. I'm going to combine my like terms and do all that stuff. And what we're going to have is a quadratic, right? Because the highest power I see, and that's pretty typical for these, but you'll see a couple maybe that say have an x cubed or something. We saw some with x to the 4th, so it's possible to have things outside of just quadratic, but it's pretty common. All right, so I have y squared. All right, so I have my 12y minus my 5y, which is going to be 7y. Okay, actually let me write that a little nicer. Okay, now I have a minus, actually let me mark off the things I've done already. This is getting kind of cluttered. Right now I have a minus 5 plus 36, so that's going to be plus 31 is equal to 25. Okay, it looks a lot nicer now. Now we'll move that 25 over to get that 31 minus 25. So we'll subtract 25 on both sides. And we'll get y squared plus 7y plus 6 is equal to 0. And this should factor. All right, let's see. Yeah, factors of 6, that will sum up to be 7. 6 and 1. Okay. Because 6 times 1 is 6, 6 plus 1 is 7. So y is -1 or y is -6. Okay. So now let's go back, because we found our y's, but we need to find our x's now. And here's where we're going to use our square root thing, right? If x squared is -5y minus 5, okay, when y is equal to -1, right, we get x squared is equal to -5 times -1 minus 5. So x squared is equal to, that'll be 5 minus 5, so x squared is equal to 0. So x is equal to 0. Okay. So we have 0, -1. So our point is 0, -1. Okay. Put a red box around our actual solution here. Okay, so remember, it all together is our one of our solutions. All right, so there's our first solution. So that's when y is equal to 1. So I'm going to put a check mark there to know I took care of that case. Okay. All right, when y is equal to -6, that means x squared is going to be -5 times -6 minus 5. Okay, so that is going to be 30 minus 5. So x squared is going to be 25. Meaning x, remember, is going to be plus or minus the square root of 25, so x will be plus or minus 5. Okay, so x equals 6 gave me both plus or minus 5. Okay, so I have x equals positive 5 and y equals -6. And I have, when x is equal to -5, y is -6. We get both here. Okay, so I think the toughest part about some of these is making sure you get the right points and you get everything exactly the way you need, and you get every possibility. Okay. All right, so I think that's enough examples there. Like always, if you have any questions, let me know. And unless the order of these things change as time goes on, this will be the last one, so I won't actually see you on the next one. But then again, that all depends. The order of these might change around, and you might be hearing this maybe second to last, or maybe halfway through the semester, for all I know. But in any case, as always, if you have questions, let me know. And yeah.